Okay, so today I'm going to tell you something about Websockets and what actually happened at Agora when we tried to build some applications that used Websockets to push some information from the server to the client. And I'd like to start with, well, I said ident, so that's a protocol. So let's keep with that. And who am I? My name is Michał Czapracki. I'm a programmer for a long time. I did connect to a remote system in 1992. Developed the first websites in 1995. Then I was grounded, of course, because I did some extensive phone bills. And I did the first earnings in 1998. First serious job, 2001. And since 2010, I'm head of video development at Agora SA. So Agora SA, Agora.pl, it's one of the first Polish companies. It's the biggest Polish-owned media company. We've got cinemas, newspapers, radio stations, web portals, advertising companies, and more. Actually, we do lots of stuff, and as like a big corporation, it's quite normal. We've got over 3,000 employees, and since 2010, one of those employees, it's me, actually. So WebSockets. How many of you have tried to do something with WebSockets or seen? Oh yeah. So have you actually found fall into any pitfalls with it, or had any problems with it, or was it just simple? So my pitfall was we didn't know how to scale the application, and we didn't know how the WebSockets were working for an application. We didn't know how much downloads we'll get. And therefore, this in 2012, this was a brand new technology. So, what are WebSockets? It's actually a W3C standard. So it's basically standardized, and you can rely on the protocol. It's widely implemented in the browsers. It's working in Internet Explorer. It's working in Firefox, Chrome, Safari. Also in some of the latest browsers on mobile phones. And there are lots of frameworks on client and server side that you could use. So where could they be used? What they're for? Since this is communication that is bidirectional, you can use for online gaming, so you can send data from server to the client and back. You can do messenger apps, and that's quite easy. You can do tracking of long-running server operations. More interesting for me was the bit that said live feeds. So anything happens, we just push the information to the server. And actually, every kind of a server-side event-based scenario is actually a nice place to use WebSockets, so you can get the information to the client as soon as possible. Okay, so how did the world manage when there was no WebSockets? Well, we did use HTTP polling, which is actually some continuous requests to the same server. We did use long polling, so it's just a very long working server. So the server didn't reply unless it had anything to say to the client. And of course, bare TCP sockets using plugins like Flash, Silverlight, or perhaps, I don't know, Java. Well, actually, it didn't. So when WebSockets came in, everything started to roll much easier, because before WebSockets, the only companies that could afford to build such, use any of these three systems in scale were companies as big as Facebook or Google. And right now, we believe every company, every even the smallest startup, can use WebSockets in extensive scales. So pros and cons. So you got instant communication. I'm going to show you that in an example later. You get much lower bandwidth usage, so you don't have to send the information every time. You don't have to put headers there and back from the HTTP server. You got duplex communication, which is something that wasn't really there before. And there are lots of native libraries that you could use. So you could use it on the iPhone, and you've got a library for that. You can use it on the desktop, and you've got a library for that. I don't know, .NET or C++, whatever you use. But there are also problems. So large number of concurrent connections. You before WebSockets, we were kind of used to handling lots of requests per second. This is not the case right now because we, with WebSockets, we have to handle lots of simultaneous requests, and they live for a long time. So you need to get hold of that. It's a bit hard to implement it in standard framework. By standard framework, I mean like servlet in Java or perhaps PHP. It's quite tricky because those frameworks are built with thinking about requests and responses. This doesn't work this way, and which is the most problem. The thing that gave us the most problems. It's not compatible with web proxies, so you can't use Varnish in front of your WebSocket connection, because it simply wouldn't work. And even if it would work, it wouldn't do any good because every connection had to be tunneled to your server. So, as I said, no caching layer. There was completely nothing that we could use. So the other thing is live applications. So we were given a challenge. The internet was always dreaming of a cheap way to be better than traditional media like television. So how fast can we put an information to the client? The simplest way is, of course, to put it on a website. But then the client has to go into the website, refresh it. Then you got like you have to write the information, etc., etc. So WebSockets gave an opportunity to build application that constantly sends the information or receives the information over a long-running socket. And Agora did think that this is a nice place to be, and we decided that we want to build such an application. We start with the sports portal, so that was the SportPL live application. That's one of the biggest Polish applications in sport, I think, and it was the first one that implemented this kind of really live scores and really live traffic and information. So we had like big estimations because SportPL portal is really big. In Poland, it's one of the biggest portals, sport portals. I think it's the #1, but it sometimes changes. So I'm not absolutely sure. So we thought, yeah, it's gonna get lots of downloads. So the first months told us, well, the estimations that we made about downloads weren't exaggerated. They were really true. And our middleware had a hard time processing the requests. And well, scaling it horizontally, well, if you get like a really short time, so it was a month, we couldn't get more servers put in place, and it took time. So we had to do something quickly. And we found that most of the processing time was taken by the traffic that we could not cache. It was WebSockets, because everything else we could cache through Varnish or Squid or whatever kind of web proxy that you could put in front of a web server. So the solution, we decided that we need to create a software that would actually handle the task. So we thought, let the middleware have just a single connection, and let's proxy and broadcast those messages from this middleware to our users. And so we built something that we call DIASP. So DIASP is a socket proxy. That's a kind of old school naming convention, but we liked it, and it's pronounceable, so that's good. So these are the apps. And this is Gazeta PL Live, and this is the Sport PL Live. So this was the first one. That was the other one that we decided to, after the success of the first one, then we decided to build another one. And well, DIASP was obviously necessary. So what did we get from that? Well, right now, Sport PL Live and Gazeta PL Live has together have over 2 million downloads in iOS, Android, and Windows Phone. I know that for some of you, it might not be a big number since it's outside Poland. If you target your application globally, that may be bigger numbers. But in our case, it's quite big. We got just 6 DIASP instances, and well, actually, they're not doing anything. They're just sitting mostly idle. Even if we get like 20,000 connections when we had the Euro 2012 football championship in Poland, then we had like really big numbers of connections, and I was on a if I recall, I think there were 2 servers back then, and it wasn't really very hard for the servers to cope with that. And all we need to host is a single instance. Is just 300 megs of RAM and a bit of processor power. So you don't need like very strong servers. It's just pushing the requests there and forth. So I'm not going to tell you that a Raspberry Pi could run this, but a small server, I think so. And well, we did some extensive testing. We needed to have a server that had DIASP, so we put it in our data center, and well, we did test it from our own computers. In the lab, and well, we broke all the routers that went from our workplace to our DIASP server, but not DIASP. Okay, so there are some questions perhaps that need answers. So what is DIASP? DIASP is unidirectional, and that's quite important. It's a WebSocket proxy server module written in Node.js. So like a web proxy, it's designed to handle lots of clients connections and use up just a single upstream connection. So you get less computing power in your middleware, which is probably doing other stuff. It doesn't need to worry about WebSockets. And it actually lets you send anything from the server to the client, but it blocks all the incoming communication. So it's mostly the same as with ordinary caching layers, except it works the other way. So it's unidirectional. Okay, so what does DIASP do? Well, when you set up your DIASP instance, DIASP will start an HTTP WebSocket server when a client connects, and that's not before that. It connects to your middleware, and it will any message that comes through WebSockets from your client from your server to DIASP, it will be posted to your clients. And DIASP will also translate plain WebSockets into Socket.io, and if you implement it, well, any other means of communication like static sockets or anything else. And why am I telling you this? Because yesterday I just put DIASP on GitHub. So this is the address, and well, you can install it from npm, modify it, check out one of the examples, run it, and see whether it fits your needs. And how to do it? Well, you have to have well, Node.js 06 at least. I tested it with 06, 08, and 010. and it kind of works except for plain WebSockets, which we are going to fix in the following days. But I'm going to tell you this a bit later. So, how to install Node.js? You can use it. Use a package manager. You can grab it from your binary from Node.js org, or build from source. The third option is, of course, a bit more complicated, but it also works. Then, well, install DIASP. That's relatively easy, I think. And you can run the DIASP sample. So we built, I'm going to show you this in a second. So this WebSocket server, you can start it. You can post some messages to that. So that's our middleware example. And then you start your DIASP instance. So there's a sample for that as well. And then you point your browser to wherever you've got your client files. And if you like to test it right now, so this is a QR code. You may connect to this place. I'm going to try it right now. I'm going to show you what actually happens, but not on the phone. I want to see the outcome. And perhaps you'll see. OK, so this is my example. It's not very complicated. I hope you can see anything on the big screen. But yeah, let's just try this. And this other thing is the client website that you can see on your smartphones if you connect it to that. And if I write here, for example, Atmosphere Conference and I don't know, another URL, we're going to send such a message. And if I go to here, then you can see how much. Has anybody connected to the server? I cannot see. Yeah. So you could see how fast this actually works. So when I write, if I push enter right now, then it's going to come onto your screens mostly in I don't know, 20 milliseconds or so. So I'm going to do a quick test, and let's see how it works. Yeah. Well, there you are. That's our example, and I'm going to tell you what's next. Within the next month, we want to start working on a better way of going through different types of connections. So you'll have bare sockets and WebSockets and Socket.io really working well and quite quickly. And the other thing is that right now, DIASP is just a module in Node.js, so you have to, I don't know, install it somewhere or maybe use it as a dependency for your server and configure it programmatically. We've got, or maybe we've published another Node.js software that's called Base Controller. And it helps you start a server. So we're going to connect DIASP and Base Controller so that you could use DIASP and configure DIASP. Well, I'd say wherever, if you've got like a socket connection, then you'll be able to just connect to the socket and configure it in any file. So that's going to be relatively easy. And moreover, I think we're going to put DIASP onto the bigger scale. So if any of you would think that DIASP might be useful in your company and you would like to try it, then we would definitely help you and support, well, a big scale scenario for DIASP that's different than ours. Yeah, and thanks. And if we've got some questions, perhaps. Yep. There's one.
I got a question about failover. Do you handle failovers of DIASP servers?
Yeah, because well, in the front we of course built a VIP network between a couple of DIASP servers. So that's a failover over DIASP, and below that, so of course, if one of the middlewares doesn't work, actually, I think I could show you that because no, I couldn't because I have just a single instance. But if I got like 2 instances of the same server or the same middleware, I could disconnect one. DIASP would disconnect from that, try the other one, and well, it's actually right now it's just a round-robin implementation, so it needs probably exporting to a different module, but yeah, you can just put a multiple. So let's say 2 servers, 2 upstream servers, and then just put a couple of DIASP instances in front of that, and it will work, and it will fail nicely.
Yeah, I wanted to ask how many concurrent connections maximum you have right now. So what's
well, we managed to. Well, before we burned the routers, it was 30,000 connections. It was working. I'm not sure how fast it was working because we couldn't tell because the routers weren't going either our way or other way. So the only thing I know is that 30,000 concurrent connections is not really a challenge for DIASP. So perhaps it could get over. I'm not sure because some people said that they've made implementation of Node.js WebSockets with over 100,000 connections to that. Perhaps I couldn't get that number of connections in tests. So we actually thought that 20 to 30,000 is really okay. So we're good with that, and yeah, perhaps a new test scenario would be necessary.
Thanks.